Let's take another look at function tables and function rules. So first off, looking at function tables, what I want you to do is to highlight the x values, which are inputs, and know that they would be going in where the x is, and highlighting the y. And if there were y values, that's where the y would plug in. So for this first one, 16, we are plugging that in where x is, okay? So y is equal to 4 times an x value of 16 plus 1. 4 times 16, I plug that into the calculator, I get 64. Bring down the plus 1. So I add those together, 64 plus 1 is 65. So the y value is equal to 65. Okay, the next one here, 3, is in our input. It's an x value. So again, same thing, that's being plugged in where the x is. So y is equal to 4 times an x value of 3 plus 1. So I'm calculating 4 times 3 is 12. Bring down the plus 1. 12 plus 1 is 13. So our y value, our output is 13. Okay, looking at the second example. Again, I'm going to highlight my inputs, my x values are plugging in where the x is in the equation. And our output, our y values, will plug in for y. So this 7 here is going to plug in for x. So we don't know y. It is equal to 12 times our unknown, or our x value of 7. So I'm calculating 12 times 7 is 84. So our y is equal to 84. The reverse happens here where we're given the output. We are plugging that in where y is. So the 132 is going where y is. Bring down the equals, bring down the 12x. This time, we need to solve for x. Since x is being multiplied by 12, the opposite is to divide each side by 12. On that side, it cancels out. We are left with just x equals, I plug into my calculator, 132 divided by 12 is 11. So our input, our x value, would be 11. Okay, let's look at number 3. Again, I'm going to highlight my x values that are plugging in for x and my y values that are plugging in for the y here. So we are going to look at the part y. We've got y equals our x value of 106 minus 10. So I'm going to calculate 106 minus 10 is 96. So our y value is 96. Versus the reverse here, we've got 52 as our y. We are plugging that in for y. So 52 is equal to x minus 10. Now we have an equation that needs to be solved. We are subtracting 10, so the opposite would be to add 10 to both sides. It cancels out over here. We're left with x equals 52 plus 10 is 62, so that tells us our input value would be 62. Over here again, let's start our highlighting. Our x values we are highlighting so we know that that plugs in where the x goes. Our y values we are highlighting because we know that plugs in where the y is. So the first one, we are given y value of 224. We're going to plug that in for y. So 224 equals, bring down 14x. We have an equation to solve then. X is being multiplied by 14. The opposite is to divide each side by 14. On this side, it cancels. We're left with just x equals 224 divided by 14 is 16. So our x value is 16. Versus the next one, we are given the x, so that's plug in for the x here. So we don't know y. It's equal to 14 times an x value of 40. So I'm plugging that into my calculator. 14 times 40 is equal to 560. So that was a little refresher on function tables. Let's now look at function rules. So for function rules, we know the equation is going to be y equals. What we want is to find where the x, or the input, is going up by 1. So from 2 to 5, that doesn't go up by 1. From 5 to 6, that does. So I'm going to highlight both of these rows because that's where we're going to look. So our x value goes up by 1. And our y value here, what does that go up by? Well, 15, 16, 17, 18. It goes up by 3. If you didn't know how to do that, you can plug into your calculator. 18 minus 15 is 3. Or if you had done 15 minus 18, that would be negative 3, and we would just ignore the negative sign. So since it goes up by 3, where the x goes up by 1, that tells us that 3x is going to be in the equation. So we're going to plug it over here and see if it works. So we're going to do 3 times each input. So I did 3, and I'm going to plug in each input. So for the first one, we're plugging in 2. 3 times 2 is 6. Is that what my output was? Yes, that worked. Let's double check. 3, plug in 5. 3 times 5 is 15, which matches. Plug in 6. 3 times 6 is 18. That matches. Plug in 7. 3 times 7 is 21. That matches. So each time it matched, that tells me my equation is going to stay y equals 3x. And now I can solve for that unknown value. We're doing 3 times our x value of 10, which is 30. So that unknown value is 30. All right, next one, function equation again. We know it's going to be y equals. I'm looking for where the x value goes up by 1. So from 4 to 6, that doesn't go up by 1. 6 to 7, that does. So I'm going to highlight those rows there. My x values went up by 1. What did my y values go up by? So I can count 42, 43, 44, 45, 46, 47 is 6. But if I don't know how to do that in my head, I can just subtract. 47 minus 41 gives me a difference of 6. So since it went up by 6, that tells me that 6x is in my equation. So we're going to plug it in over here and test it out. So we're doing 6 times our input, which the first one is 4. 6 times 4, I plug that into the calculator, I get 24. Does that match here? No. How much more do I need to get to 29? 25, 26, 27, 28, 29. I need to add 5. That will give me 29. Let's double check the next one. 6 times our input of 6. When I plug that in, I would get 36, which does not equal 41. So if I add 5, 37, 38, 39, 40, 41, that will get me to 41. So we're seeing the pattern here. Let's try it with 7. 6 times the input of 7. When I multiply that, I get 42. That does not match 47, but let's see. If I add 5, will it work? 43, 44, 45, 46, 47. And one more for good measure. 6 times 9. When I multiply that, I get 54. That doesn't give me 59, but how far away is that? 55, 56, 57, 58, 59. It was 5 away, so it matches. So since each time I had to add 5, that tells me that I need to add 5 in my equation. So now for our unknown value 13, I'm going to plug in 6 times 13, which is 78. Add 5 to that, and that gives me the unknown answer of 83. All right, let's try one more. So again, we know our equation is going to be y equals. I'm looking for where my x values go up by 1. 2 to 4, nope. 4 to 8, nope. 8 to 9, yep, that works. So my x values went up by 1. The corresponding y values are going up by 2 because 21, 22, 23. So we are adding 2 here, which tells me that 2x should be in my equation. Let's plug it in over here and see what works. So 2 times our input of 2 is 4. That's not 9. How much do I need to add to get to 9? 5, 6, 7, 8, 9. So I need to add 5 more. Let's try it for 4 and see if it works. 2 times our input of 4 is 8. What do I need to add to get to 13? 9, 10, 11, 12, 13. So I need 5 more. That gets me to 13. Let's try it with 8. 2 times our input of 8 is 16. Plus, how do I get to 21? 17, 18, 19, 20, 21. We are adding 5. And one more, 2 times our input of 9 is equal to 18. How much more to get to 23? 19, 20, 21, 22, 23. We are adding 5. So each time it works that I need to add 5 to my equation. So we can use that equation to solve for our unknown. We're plugging in 2 times our input of 10, which is 20, and then we need to add 5 to get our output of 25.